All right, section 5.8 is really mainly a section that's on your graphing calculator. So for those of you that love your graphing calculator, this should be a fairly easy section. I'm just going to go through a little bit of terminology for the intro video, and then we'll dive into some problems. So the first set of terminology, I guess, that you're going to have to be familiar with is local maximum and local minimum. So local max is the y-coordinate of a turning point if the point is higher than all nearby points, and local min is the y-coordinate of a turning point if the point is lower than all nearby points. And let me just explain this maybe in a little easier light here. If you have a quartic function, and let's say it looks like this, your local maximums would be this point and this point. So it's not necessarily the highest point. You could have several maximums, and that's why they're called local. So it's just higher than all the other points around it. This one is higher than all the other points around it. I think you get the idea. So any maximum point is a local maximum. And then, of course, on the flip side of that, any point that's lower than any other points below it, around it, excuse me. So this right there would be your local minimum, and that is it. So those are local max and min. So basically just any max and min. So that's pretty straightforward. Okay, other things, you really should know all of these words, but I'm going to remind you that they're super important and that you know what they mean, because a problem is going to use all of these words. So again, you don't need to write this down, but let's just say f of x is a polynomial function. Okay, so this is some polynomial function, and k is a real number, then the following statements are equivalent. Okay, so you know that the definition of zero is that k is a zero of the polynomial function. So if I put, let's say I told you that 2 was a zero, k would be 2, and when you put 2 in for all of the x's of the polynomial function, you should get it to equal 0. So that's just telling you it's a 0. If you know k is a 0, then you know x minus k is a factor of that polynomial function. So if I know that I have a 0 at 2, I know that x minus 2 is a factor. Or if I have a 0 at negative 4, I know x minus a negative 4 or x plus 4 would be a factor. And again, you should really be pretty solid with these concepts. So going from a 0 to an x-intercept. Solution is just another word for a 0. So k is a solution of the polynomial function if f of x equals 0. I'm sorry, that should be f of k, now that I see that here. So this should be f of k equals 0. I'm using k's and x's here, sorry about that. So again, if I knew that 2 was a solution, when I did f of 2 or put 2 in for the polynomial function, I should get it to equal 0, and that tells me that truly it is a solution. And the last word, x-intercept, yet another 0, solution, x-intercept, they're really all the same thing, but you know that k is an x-intercept of the graph if it contains the point k0. So again, if you put k into the polynomial function, you should get 0 for your output, your y value, your f of x value, whatever you may call it. So have these words down, because problems are going to say, given a 0, or if you know a factor, or if this is a solution, and you just, you have to make sure you understand what those words are.